All right, let's dive right in. For decades, we've had this standard story about how the brain works. But today, we're going to explore a really radical new idea that reframes pretty much everything, looking at the brain not just as a computer, but as an actual physical machine. You've heard this a million times, right? The brain is like a supercomputer, this tangled web of wires and electrical signals. And it's a powerful metaphor. But what if it's missing a huge piece of the puzzle? What if the brain's physical, mechanical nature is way more important than we ever thought? And right here, you can see the huge contrast. We're shifting from the standard view, the brain as an electrical circuit, to a completely new idea, a physical system, where our thoughts are literally created by motion and force moving through the brain tissue itself. I mean, that is a massive shift in thinking. To get our heads around this, we have to talk about one key concept, mechanosensitivity. It's just the built-in ability of our cells, and yeah, that includes our brain cells, to feel and react to physical force. Now, this isn't some new discovery in biology, but applying it as the main driver of thought, that's the revolutionary part. So, this new way of looking at things has been organized into a really powerful framework. It's called the Brain Kinematics Model, or BKM for short. And you can think of it as our new guide for exploring the brain as a physical, mechanical system. Now, what's so important here is that the BKM isn't trying to throw out decades of neuroscience. Not at all. As this quote explains, the whole point is to align with what we already know, to give us a new physical language for concepts we're already familiar with. And here's the best way to picture it. Just forget the idea of a computer chip for a second, and imagine the brain as this soft, responsive gel. In this model, a neural signal isn't just an electrical blip, it's a physical push that sends a tiny ripple, a literal wave of strain, moving right through the tissue. Okay, so how does this actually work? Well, this is where it gets really fascinating. The BKN basically acts as a translator, taking these familiar ideas from neuroscience and giving them a powerful new physical meaning. This table, this is basically the Rosetta Stone for the Brain Kinematics Model. It shows us exactly how to translate the old electrical language into the new physical one. So let's break down each of these one by one. First up, neural pathways. We've always thought of these as fixed wires, like a wiring diagram. But the BKM reimagines them as strain flow. Think dynamic, flexible highways, where physical force and stress are actually moving through the brain tissue, kind of like currents flowing in water. Next, you've got the classic neuron spike, the action potential. In the BKM, this isn't just some abstract signal. It's a strain package. It's a literal, concentrated pulse of physical force being delivered from one neuron to the next. Information actually becomes physical impact. And finally, we have brain waves. The alpha, beta, and gamma rhythms you probably heard of. The BKM translates these into phase waves, so they're not just electrical patterns anymore. They're huge, coordinated physical ripples of strain that are literally washing across large regions of the brain. Okay, so we've got all these new terms. But how do they all connect to create something as complex as a thought, or a memory, or a feeling? Well, the real power of the BKM is how it bridges the gap from the tiniest little events to whole brain activity. And you can see exactly how it all scales up. It starts with one tiny physical push, a strain package, at a single synapse. Then enough of those create a local strain flow. And when those flows synchronize, they merge into a massive brain-wide phase wave. And that is how you might get from a single physical push to a wave of thought. So why does this matter so much? Because it might offer a physical explanation for a huge mystery in neuroscience called dynamic functional connectivity. That's just a fancy term for the brain's incredible ability to have different regions form and dissolve teams on the fly to handle different tasks. These phase waves could be the physical mechanism that lets that happen so incredibly fast. But look, a good scientific model has to do more than just describe things in a new way. It has to make predictions that we can actually go out and test. And this is where the Brain Kinematics Model really starts to shine. The BKM makes count 'em, 4 key predictions that scientists can test right now. And that's what turns this from just a cool idea into a genuine scientific theory. All right, let's unpack these, because this is where the rubber meets the road. First, it predicts that the physical stiffness of brain tissue can act like a filter. So just like sound travels differently through water than air, some of these strain waves will pass through certain brain areas more easily, just based on their physical properties. Second, it suggests we could actually map specific mental states like deep focus or daydreaming to unique physical wave patterns. It's like having a weather map for your thoughts. Third, it proposes our brain cells have mechanosensitivity windows, specific times when they're more or less receptive to these physical forces, which adds a whole new layer of timing. And finally, and this one's a biggie, it predicts that physical strain can directly control the brain's key communication hubs, basically turning the volume up or down on entire networks. Every single one of these is a concrete, testable idea. And this is the real payoff. This isn't just swapping some words around, it's a whole new toolkit. Thinking about the brain in this physical way could unlock new approaches for understanding cognition, the mysteries of sleep, and it might even give us a new angle for looking at brain disorders that are tied to the physical state of the brain tissue.
So I'll leave you with this thought. If every single thought, every memory, every feeling you have is accompanied by a physical ripple moving through the very fabric of your brain, a literal wave of strain, what does that truly mean for the nature of the mind itself? It's a pretty profound question this new model forces us all to ask.